again to another episode and an interesting section with us here at your study part. It's nice having you once again. The last time we had our physics class, I talked about the instances for which you should get prepared for an exciting time out in terms of what preparing for your UTME examination come 2024/2025 edition. Now, here is it. In our last instance, I specified certain things that would help you boost and accelerate your preparation and your preparedness towards this examination. One of which I told you, you need your calculators ready so that you cross-check values yourself, so that you build your speed and momentum, as well as your writing material. So let's get started. Now, having noted that in physics, 5 branches of physics, which all your topics are spread across. Number one, we talk about heat and temperature. Number two, we talk about mechanics. Number three, we talk about waves, where we go into optics, that is light, and we deal with sound. So questions under optics and sound, light and sound. Number four, we deal with electricity, both at the primary level, direct current level, and also under the alternating current level, which we deal with AC circuits. Also, not forgetting, we deal with magnetism. So Faraday's law of electromagnetic induction, magnetism, Earth's magnetic field, among other things, is embedded under this number 5. Number 6 is where we explore atomic and nuclear physics. So these are the 6 aspects which we are focusing on in terms of our Jamb review come from now till next year when your exam will take place. So get prepared. Now, here is it. As much as possible, we want to explore some of the calculation instances which you should be familiar with. Then along the line, we get into place balancing out with the non-calculation aspects. For review today, we'll be looking at heat and temperature. What are the likely calculation questions you tend to have surrounding heat and temperature? Something on the light note. Trust me, it's something for which you pick up as fast as possible and you're able to deliver in the shortest possible time. So let's get right into it. Talking about heat and temperature, what is the focus under this instance? The following. We need to understand the rudiments of temperature conversion. You should be familiar with how to convert one temperature to another. And based on what we've learned from primary school and perhaps junior secondary school, you're familiar with the formula that stipulates that degree Fahrenheit is equal to, remember, 9/5 degrees Celsius plus 32. I'm actually sure some have actually forgotten this. We talk about degrees Celsius as being 5/9 degree Fahrenheit. Note, minus 32. Now, you don't want to start putting all this in your head. Why? There's actually a scale range which we use because now that you are in your senior secondary school level, there are certain temperature scales which you tend to see in your UTME examination, talking about resistance thermometer scale, talking about volume gas thermometer scale, talking about pressure scale, among various other different skills which you are going to be having now. So it's not to streamline and limit yourself to only this formula or peradventure adding this guy to it, because I know many of us are familiar with just these 3 instances. No, we go beyond the scope of these 3 skills. That's why I tell you that what you want to master the art of solving questions under scale conversion. Then you go this line. You note exactly what the degree Celsius scale would be. Here we call it the upper limit. The upper limit for degrees Celsius, we're working with 100 degrees Celsius. The lower limit, we're working with 0 degrees Celsius. When we pick our Fahrenheit scale, we're working with 212 degree Fahrenheit here, 32 degree Fahrenheit here for the Fahrenheit scale. For our Kelvin scale, we're working with 273 Kelvin here, and we're working with 373 Kelvin here. Kelvin. Last but not the least, we are working with our random scales. Note, random scales, meaning any other scale which we can be given. I call it the X scale. You work with the temperature of value at 100 degrees Celsius. We work with the value at 0 degrees Celsius relative to the middle value, relative to the middle value here, relative to the middle value here, relative to the middle value here. So what do we mean by this? It means that any value you are going to be given, this part is the lower fixed point. Or let's call it fixed point. The lower fixed point. Here we have the upper fixed point. So understand that what every value you are going to be given will work under the precept of degrees Celsius. You can have it whichever way. C minus 0, meaning the middle minus the lower, divided by the upper limit minus the lower limit. It will be equal to any other scale, working with the temperature at the middle scale minus the temperature at the lower scale, divided by temperature at 100 degrees Celsius minus temperature at 0 Celsius. So what are we following? We're actually following the middle point minus the lower fixed point divided by the upper fixed point minus the lower fixed point. This is all Jamb needs you to know, that anytime we are having any temperature scale whatsoever, always follow the rule that comparing any temperature scale, you are working with the mid value minus the lower fixed point of that temperature scale divided by the upper fixed point of that temperature minus the lower fixed point. Let's put it into practice. It's not just for you to have a formula. Let's utilize it in solving questions. So we don't have to worry about these aspects. It can be any question whatsoever. I repeat, any question whatsoever. So for the first one today, we work with question 1, which says this. Check this out. Question 1. The lower and upper fixed points of a thermometer are 30 millimeter and 180 millimeter, respectively. Full stop. Calculate the temperature calculate the temperature in degrees Celsius when the thermometer reads 45 millimeter. So a question, let's put it to use. We said that what everything we are relating, working with, we relate degree Celsius scale or Fahrenheit scale or Kelvin scale with any other type of what? Thermometer. This time around, we are having a thermometer, but note the readings here. We are told that the lower first, 30 first, the upper next, 180 next. So let's represent this in what? A scale format. We are going to have our solution. Here, let's call the thermometer X, and let's call our degree Celsius scale out. The upper fixed point here, upper fixed point for the thermometer, which we don't know what type of thermometer in this case, we call it 180 mm. The lower part, we call it 30 mm. Lower fixed point. Here, for degree Celsius, it's a constant value. Jamb most times streamline questions around Celsius scale. Why is that? They expect you to know what? Round up values like 0 and 100. It's easy to store in your head. Unlike what? Values like 212, 32, 273, 373, and 273. Here we have 100 degrees Celsius, 0 degrees Celsius. The middle value here was given as 45 millimeter. Here we are asked what is going to be the corresponding value on the degree Celsius scale. So follow the line. The middle minus the lower divided by the upper minus the lower, as the formula entails. So we're going to have 45 minus 30 divided by, here we go, 180. Note this, we have a formula which we are following. We have a formula which we're following, which is x at the midpoint, x at the midpoint minus x at the lower point divided by x at the 100 value minus x at the lower point. Comparing it with the degree Celsius part, c minus 0 over 100 minus 0. So working with the values here, we have 45 minus 30 divided by 180 minus 30 should be equal to c minus 0, which we don't know, divided by 100 minus 0. Subtracting our values, 150, 15 here, then 150 here, equals c over 100. We know for a start here, 15 here 1, 15 here 10. So we are working with 1 over 10 equal to c over 100. Cross multiplying, 10c equals 100. C becomes, C equals 10 degrees Celsius. Just as simple as that. So we can pick up the next question quickly so as not to waste time. Anytime you are giving questions, always watch out for what? The value which we are given. How to relate them in terms of what? The corresponding values. Now look at this. This is 1992, year 1992. Talking about, okay, let's pick the 1991. We're having a thermometer which we are told has an arbitrary scale. An arbitrary scale means that what? The scale does not exist. It's just an imaginary scale. So let me rub this off and put in the question, please. I might be a bit fast because we're trying to work with time, covering as much as possible. But remember to drop your questions in as the flow continues. I'll be what? Visiting some of them. So here is it now. We want to look at question 2 quickly. That's why I said have your writing gears in place. You can always screenshot. Also, you can have take a screenshot of what we have so that it also helps you out in terms of revisiting such questions. Number 2 now. Remember, we are not cleaning this off. This is the guideline of every bit of formulas and questions we are solving. Now, check this out. talking about an arbitrary what? Thermometer. The question goes thus. A thermometer with an arbitrary scale S of equal division registers minus 30 degree S. Registers minus 30 degree S at the ice point and plus 90 degree S at the steam point. Full stop. Calculate the Celsius temperature. Calculate the Celsius temperature corresponding to 60 degree S. An arbitrary what? An arbitrary scale. Note that. So there we have the question. Let's look at it. The thermometer actually has equal division such that at ice point, now we know that what for degree Celsius scale, there's always what two values we work with. We have two values we work with, 0 degrees Celsius and 100 degrees Celsius. 0 representing the lower fixed point. And certainly when we are working with the lower fixed point, you know we are making reference towards the ice point, the freezing point. Anytime we are making reference to the upper fixed point, which is 100 degrees Celsius, we know that's the temperature at which water boils. We say steam point, we call it boiling point. So working with that, we represent this in what? A scale format. So let's have it. I'll leave the degree Celsius instance. I clean off the X approach such that we're now going to have this line. And instead of X, we are working with what? S, because the scale is actually what? An S scale. Minus 30 degree S at ice point, meaning that what? At 0 degrees Celsius, we have minus 30 degree S. While at 100 degrees Celsius, which is at steam point, we have plus 90 degree S. We have a mid value here, which is what? 60 S. So we are told at 60 S, what is going to be the corresponding value on the Celsius scale? The formula has not changed. Mid value minus the lower fixed point divided by upper fixed point minus the lower fixed point. This guy minus this guy over the upper minus the lower. As such, we say that S now at 100, no, S at the mid value minus S at the 0 degree Celsius scale should divide S at the 100 value minus S at the 0 value, being equal to C minus 0 over 100 minus 0. Putting in our values, mid value 60 minus 30. Note what happens here. We are to subtract the corresponding values from each other, but our value here has a preceding minus in front of it. It has a minus, which is not the same as the minus which we are using here. That's why I have it in brackets. Divided by 90 minus 30 here should be equal to C minus 0 over 100 minus 0. From here, we know 60 minus minus gives us 30. Here, 90 minus minus gives us a plus 30 equals to C over 100. And this leaves us with 90 divided by what? 120 being equal to C over 100. 0 knocking out each. 9 and this value We have that 3 here 3, 3 here 4. So cross multiplying, we are having that what 4c should be equal to 3 times 100. Dividing through by 4 here, 4 and 100 we have 25. So 3 times 25 gives us what? 75 degrees Celsius. This gives us what? 75 degrees Celsius. So what are we trying to say? First, note the negative value here, how we calculated it. Minus and minus translate to plus according to your mathematics representation. Two negative signs plus. The same signs will always what give us plus as the single product sign. So here we have it. 60 and 30 gives us 90 addition. 90 plus 30 gives us 120. C over 100. We tend to divide 90 and 120. We have 3 over 4. It's the 3 over 4 we cross multiplied. 3 over 4 being equal to C over 100, then cross multiplying. This leaves us with what? 4C divided by 300. And our final answer becomes 75. So there we have it. There's nothing too much to flog on talking about this aspect. The formulas are there. Just note that you are working with what? The upper fixed points, the lower fixed points, then the mid value, which you are going to be given. And you relate it, whichever thermometer you are given, an arbitrary thermometer, a faulty thermometer, a resistance thermometer, a platinum thermometer, whatever the name of the thermometer is, always know that what? The mid value minus the lower fixed point, it's going to divide the upper fixed point minus the lower fixed point. And you relate what? With degrees Celsius. And you are good to go. So one aspect taken away. Let's go to the next aspect. Talking about what? The specific heat capacity instance. The specific heat capacity instance. So that's the next phase, which you can have under what? Heat and temperature. Under heat and temperature. So quickly. Specific heat capacity. So with respect to specific heat capacity, we'll be working with the following. Number one, alphabet C. Under specific capacity, you should note that what? It's either you're asked to calculate the heat energy. Heat energy. And heat energy, alphabet Q, can be calculated as MC change in theta. We have that what? Change in theta means the bigger temperature minus the lower temperature. Note, sometimes they do the what? Subtraction for you. So instead of having two temperature values, you could be given only one temperature value. So when they use English like, oh, water is heated through a temperature of 50 degrees Celsius, what they are telling you is that what? They've done a subtraction. Subtracting the what? Lower value from the what? Upper temperature value through a temperature value of 50 degrees Celsius. You don't have to start what? Looking for the second temperature value. It has been what? Carried out. The final value is what you use as your change in theta. C represents your specific heat capacity. M is the mass. Your change in temperature is delta theta, which we have here. So this is the formula for heat energy. Now, that is when temperature change is involved. When temperature change is not involved, talking about at 0 degrees Celsius or at 100 degrees Celsius, we don't use Q equal to what? MC change in theta. Rather, we say heat energy. Q becomes equal to ml. What does L represent?